Hello everyone, I am Tom Tofik from AT&T. Today we will demonstrate how SDN and ONOS can help address the challenges of managing multi-layer service provider networks. Today's service provider networks are complex and multi-layered in nature. Each of these layers, including packet and optical, is provisioned and managed independently. Provisioning and adding new service or bandwidth could require order of days, if not months. Since packet and optical networks are managed independently, each one of them has to be over-provisioned to deal with traffic anomalies and failures. This leads to lack of service agility and is a significant source of CapEx and OpEx overhead for the network operator. A converged SDN-centric plane for packet and optical networks can help address all of these inefficiencies. Service providers can optimize across packet and optical layers in real time for availability and economics, thereby reducing over-provisioning. They can add capacity based on traffic and other considerations in minutes instead of days or months. Failures at both packet and optical layers can be handled quickly and efficiently. With this approach, traffic can be seamlessly rerouted to the most optimal alternate path. Converged control plane not only makes network efficient, but also enables services to be created and deployed on these networks in an agile manner. Our goal today is to demonstrate a proof of concept multi-layer SDN control with ONOS. In this demo, we will demonstrate the following: provisioning of bandwidth on demand between data centers, automated handling of failures, and seamless recovery. My teammate at ON.Lab, Prasid from Fujitsu, will now demonstrate this use case.
Hi, I'm Prasid from Fujitsu. Today I will demonstrate how ONOS can control both packet and optical layers, and how optical layer can react to packet layer requests and dynamics. I would like to start the demo with an overview of the demo topology. The demo topology comprises of packet and optical switches. There are hosts H1 through H6, which represents hosts in a data center. The data path elements for packet nodes and optical nodes are emulated. The packet nodes are emulated using OVS switches, and optical nodes are emulated using Link OE. A customer could use a portal to request for bandwidth by specifying the endpoints and criteria. When the request reaches ONOS PC would traverse the underlying transport network, find a path based on criteria specified, and creates a circuit connection. This establishes a packet link being created between the switches connected to data centers. Now the hosts are able to pass traffic. We then introduce a break in the network, which will be picked up by ONOS. ONOS will find an alternate path based on original criteria specified by the user. Packet layer will be unaware of this change in path. Let me now go to the demo. What you see is a topology which shows packet and optical devices. If we want to view only the optical plane, we can select it here. To go to packet plane, you can select it here. Or to go back to both IP and optical, we select it here. Alternatively, for a better perspective on the packet and optical plane and connectivity, we can select the oblique view. As you see, there is no direct link between packet nodes. Let me create a request from SO4 location to JFK. We will make this request using ONOS UI. ONOS, on receiving this request, sets up optical path between packet nodes using an internal path computation engine. You should see a packet link created shown in the UI in orange color. You can also see how the path is realized at optical layer shown in the UI in purple color. You should also see the ping traffic going between these two locations to see the connectivity. Let us create some more requests. This time, we will use a bandwidth calendaring application to schedule a request. We will set up a request between nodes connected to hosts 10.2 and 10.6 by specifying the endpoints. We could also specify constraints for the connections which would be used by ONOS PC to compute path. If you switch to ONOS UI, there is still no packet link between these nodes. Let us run a ping between these locations to check connectivity. Let us switch back to the calendaring app to see the status of the request. You should see the status is active. Let us go back and check the status in ONOS UI. You can see a new packet link created and also the ping response between the hosts connected at these locations. Now let us create some failures along the traffic path. I'll bring down an optical link between these two locations. There are 7 flows egressing from this port on the link. As you see, the link between the two locations is inactive and the flows are rerouted to a new link. And if you look at the ping traffic, we will notice very few or no packets lost. I'll now hand over to Tom.
Today we showed how ONOS can be used to manage both packet and optical networks. Converged control of packet and optical networks will truly enable service providers to make these networks more efficient. Most important of all, this will bring agility and innovation to these networks. You can learn more about multi-layer SDN control with ONOS at onosproject.org. Thanks for watching.